246.18 grams per 1 mole, and the answer is yes, as of right now. Now, where do we go? I know, which is why I said, now where do we go? We do our thing. Yes? Well, can you do...
No more.
Okay. Try it. Go ahead.
3 moles calcium.
Ooh.
Per
Ooh.
mole calcium.
Excellent. So in a way, it's like kind of like stoichiometry, a mole ratio kind of thing, right? Because for every 1 calcium phosphate, there's 3 calcium ions. Would you guys agree? Okay, so there's 3 moles of calcium ions for every 1 mole of calcium phosphate. Awesome. We've covered that. Now what? Well, what am I looking for? How many calcium ions? We do need Avogadro's number. And now we got it. Well, okay. So, 100th, 300th, 2 times 10 to the 21st. Oh, I should make you guys do that. Nothing. I should have told you guys to have your calculators away, because you may or may or may not have mentioned this. There's 2 parts of the AP exam, just like I think all the rest of them. There's a multiple choice part. There's a free response part. The multiple choice part, you are not allowed to have your calculator. Are there math problems? Yes. You're not allowed to have your calculator. Now, how many of you remember that had me, that I wouldn't let you guys use your calculators a lot last year? We did it every day that I was doing calculations. So, put your calculators away. Now, let's do this. Don't put them away. Just turn them off. Don't touch them, except for I need 2 or 3 volunteers today. Who already has the answer already calculated? Okay, then you 3 keep your answer so we have something to compare to. The rest of us estimate the answer easily to 1 significant figure. You might be able to squeeze a second one out of this. Yes. Don't do it on paper either. We did this all the time. Okay, so here we go. To 1 significant figure, we should easily be able to get. Anyone have a result they'd like to throw out there? Brian has something. What do you have, Brian? You have nothing. You're looking at that and can come up with nothing. Kayla? What do you have? Emma? Gracie?
I mean, I think I'm wrong.
It's okay. It's our apparently first day ever doing this.
I thought it was...
Oh, well, don't...
No. It's not the right answer. I thought it was, like, 1 to the 21st. Like, 1 minus...
I got you. No, I got it. I understood what you meant. You did say it wrong, but I understood what you meant. Anyone else have anything they'd like to... What do you have? Okay, now what I'm going to do with your answer is do this. You said 23rd? I think you went the wrong way on. Okay. Whoops. That's what I came up with. You said 0.2 though.
Oh, yeah.
Anyone else have something?
I was going to say
3 to the 21st. Okay, I personally went with 2. Who said 1? You. Okay, probably not bad, and you also said 2. Okay, so here's how I would have done it. There's 18, well, I don't know if there's 18, but there's a number of different ways your brain can see this. I'll do it the way my brain saw it. It may or may not be the way your brain saw it, and that's okay. Basically what I did is rounded this to 4 and this to 200. So what's 4 200ths? Yeah, you'll see. Just because it makes my math easier. What's 4 200ths?
1/50th.
2 100ths. Right? 2 100ths. Is that what I did? Hold on. I got to make sure that's what I did. Yeah, I'm going to change my answer then. So 2 100ths. Now I've got 6 100ths. So far, so good? So, yeah, this might end up being closer to 3. And then 6 100ths times 6 is what? 36 100ths. Which is 4 100ths, right? I know. Oh, okay, 4 100ths. So I'm closer to thinking 4 now. So 4 times 10 to the 21st. Now, that's an estimate. You guys get that, right? But I'm pretty darn sure this is right, the 21st part. Okay, but again, what if you came up with 4 times 10 to the 3rd? You would know you were wrong. You know what I'm saying? You're in the ballpark. You guys need to be able to get to the ballpark very well. You're going to get really good at this. Yes?
I get how you got the 40 over the 100, and how did you get from that 23rd to 21?
Because what I say 100ths? Okay, 100ths is 0.01. So I move my decimal point 2 places to the left. You're good now. Okay. Anyway, you'll get better at that because that's what we're going to do. All right.
So on the AP exam, are they going to have the numbers like yours?
And so what's going to happen is there's going to be a difference between the order of magnitude is most important. Does that make any sense? The power of 10 is going to be the most important piece, and they'll have things like significant differences in your powers of 10.
Put like 0.2, 0.3, 0.4.
Right. You see where I'm going with that? Yeah. Okay. Well, it depends on what they're doing, but okay. So anyway, what is the actual answer?
3.47.
Okay. Does anyone concur? I disagree with that. I am.
No, I put 3.4726. I do actually have a question.
Yeah.
So, like, this is probably a stupid question, but, like, I get, like, why, like, doing it in your head, like, with how you broke it down by the fractions, but how do you do, like, the 10 to the 23rd-ish?
Was that you?
Yeah.
Okay. Remember I said something hundredths?
Yeah.
I guess I done saying this. That's okay. You were probably thinking about something else. Hundredths is 0.01, and it's small. So I had to go, going from 23rd, I just moved the decimal point 2 places.
Why didn't it?
I don't know, because I haven't done the calculation. You guys did the calculation. I haven't touched the calculator yet. I should probably touch the calculator. Did anyone get, both of you got, who all did this calculation? Okay, just to make sure that you guys are doing it right. Yeah, I got 3.47. Yeah, there we go. Times 10 to the 22nd. Yes. The only measurement that we have up there is this right there. This, even though at some point in time it was a measurement, okay, one, it's the 5 significant figures, so it doesn't matter anyway. This is not a measurement. How did we get that? We went 1, 2, 3. It was a counting thing, and that counting is never a significant figure. And this, yeah, ultimately was a measurement at some point in time, but it's also a number. It's a counting thing. Yeah, the only measurement is that very beginning one. So 4 significant figures. How many calcium ions? The number of calcium ions. Okay. A thing about significant figures. I have been doing this ever since I started teaching AP because why not start the process now? On the AP exam, they typically have a tendency, and this is on the free response part, to give you a 1 significant figure leeway. For example, who was the first one that threw out an answer out there? I forget who was that? Okay, what was the answer that was thrown out? 3.47. Okay, 3.47. Now, and then it might have been Gracie, it might have been somebody else, threw out a 3.472 something.
I did.
Okay, so either one of those would have been acceptable on the AP exam for 90% of the questions because you were within one of the correct number of significant figures. You see where I'm going with that? The correct number is 4. If you had stated your answer to 3 or 5, they wouldn't have counted off, with the exception of one problem, and you never know which one it's going to be. But they actually grade you on significant figures. So if you get the problem exactly right, but your significant figures are off, they take a point off. But it's only on one problem on the whole free response. So obviously your goal is to be as good as you can for that one time. Yes?
What is your result?
7. Not typically. It used to be typically. Now it's 7. Since they redid it. Okay. Everyone comfy, hunky-dory with what we did there. I combined like 3 things into one problem. Converting to moles, using kind of a a mole ratio kind of thing, and then using Avogadro's number. I can't do much more than that in one question. Okay. I'm going to do it just because it's been a little while for, well, all of you, it's been a little while. For some of you, it's been an even longer while. Find, and I'm doing you a favor here, percent composition by mass of so let's walk and talk this one. No, let's walk and talk it. What do we need to do? Go ahead, Gracie.
We gotta do the thing where we gotta do the average atomic mass.
And we already did that. That's why I picked this one.
And then we take that, and then we're gonna put it in.
No, we don't have to do that.
Well, I just was gonna do a mole ratio.
Yes?
So you take the atomic mass of the whole thing,
Yes?
and then you find the mass of the potassium.
Phosphorus?
Phosphorus, I know that. No, I'm so tired. Sorry, guys.
Yeah, it's been a long week.
Oh, yeah. No, yeah, it is. I knew that.
I'm just playing. You meant phosphorus.
Yeah.
So we need to find the mass of just the phosphorus. How are we going to find out the mass of just the phosphorus? Well, yeah, we're probably going to use something off of the periodic table, but what else do we need to know? How many phosphorus atoms? And how many phosphorus atoms are there? 2. So, we go 2 phosphorus. And does anyone happen to know it off the top of their head? Then you'll probably need a periodic table in front of you. Turns out it's 30.97. So what is that? 61.94. Would you guys agree? And then we divide it by, as someone said earlier, the formula mass, which, what was it, 246? 46.18 grams of the calcium phosphate, and multiply by 100, boom. This is all flooding back to you. That's easy, right? Now, back when we learned it in chemistry, usually the question was, what is the mass percent of each element, right? But I'm figuring if we know how to do one element, you know how to do the rest of the elements, so I'm not going to bother. You guys okay with that? Yeah. I had thought you might be. So now we have covered mole mass particle conversions. We have covered mass percent in approximately 10 minutes or less. Now we're going to do empirical molecular formulas in the next 15 minutes, and we'll have covered all of Chapter 7. It took you guys about 3 weeks in chemistry. Next. Well, this is stuff you know. Do you know this? Well, you have known this. You could re-know this. Next question. Okay, here we go. So this is percent composition. Next is empirical formula. Kind of interesting that I say any nitrogen atmosphere, because essentially that's what we are right now, with a little bit of oxygen thrown in. You guys knew that. What's the percent of oxygen in air in general? You can use fingers if you want. 2? What is it? No, it's 21. But still, it's the 78% is nitrogen. So most of what we're breathing in is nitrogen. Has a mass of, yeah, that's fine, is fine. Has a mass of is,
we have to figure out what it is.
well,
I understand that it's easy, but like,
what is the magnesium reacting with? Right. That's the only thing it's reacting with. Yes?
Okay, this is kind of going back to the last question, but when we are trying to find the percent, do we still use significant figures?
Oh, yeah, absolutely.
I know.
Always. If you're doing any calculations with measurements, yes. Yes. No, I get what you're saying. How is 100? No, it's a counting thing. There's 100 pieces. Yep. Hundreds don't count, yes. Yeah, because again, what you're looking there is how many grams are in a kilogram. So that 1,000 grams is a counting process. Fair question. Mainly for the people that haven't done this for a while. Okay, what are we going to do? Help me out. To get? No, your brain's doing the right thing. You're just not sure how to designate everything. So this is the product. So we have 0.378 grams of. Now, what is the stuff that we made? In this particular question, what are the components of the product? Magnesium and nitrogen. Now, we don't know the proportion that those are in, but we know it's some sort of proportion of magnesium and nitrogen. Are you guys comfortable with that idea? Great. So there's that. And as, I think it was Kaylee. Was it Kaylee? Yeah. So now you guys were different. So we're going to subtract from that the mass of the magnesium. Which is going to give us the mass of the. There we go. And if anybody can do that little. Oh, this is a good little thing. Probably in her head. I know. 0.105 grams of nitrogen. Now, does anyone remember what we do with this information when we're doing empirical formulas? Got Morgan. And that's the first step. And anybody can throw in the next step. Convert to moles. I kept saying this all the time. Convert to moles. No. Okay, let's convert to moles. What is a ratio? What mathematical operation is done? Divide. Convert to moles, divide by the smallest. You remember that? Convert to moles, divide by the smallest. I don't know. I'm not sure what you're talking about. Here? That's a Z. See the little line through it? Like me to have used a Q there. I can. It's been a really long. Alright, so around here we're looking at what, 0.01-ish? Actually, they will have you. I have seen on the AP exam, multiple choice, have you guys do empirical formula problems with no calculator. Don't get your panties in a bunch, because what will happen is things will turn out to be like 0.015 and 0.03. You see where where I'm going with that? All right, so anyway, does anybody have this? No, that's fine. And I'm telling you what, with doing empirical and molecular formula calculations, the more you have to carry along, the better off. You guys have a tendency to round off too early on these sometimes. Okay, and then the nitrogen is going to be 0.00. Okay, so there we go. We have our moles of each component. What do we do now? Divide by the smallest. In this case, it's 0.0074946. Obviously, the nitrogen is going to become 1, and the magnesium is going to be, oh, this is a great question because it covers everything. 1.495. Okay, and obviously, remember, we are not going to round something that far away. Well, the only thing we're going to round is when we're in a couple of hundredths. Okay, of course, 1.49 is incredibly close to 1.5. 0.5 represent what fractionally? Half, so we're going to multiply the entire thing by 2, which gives us Mg3N2. Now, those of you that are chemically aware, when I said magnesium and nitrogen, most of you already wrote the formula, or some of you could have written the formula down. What is the name of this, by the way? Nitride. This is a great little warm-up of remembering how to do empirical formulas. Would you guys agree? Remember, an empirical formula